Hello, my name is Sébastien Adam. This presentation aims to introduce the software architecture mapping framework to manage architectural knowledge. The related paper was published in the Software Engineering and Knowledge Engineering Conference Proceeding in 2016. This presentation describes the problem addressed by the software architecture mapping framework, the research methodology conducted to develop the SAM framework, my proposals to manage architectural knowledge, the activities conducted to evaluate my proposals, and contributions and future work. I invite you to follow the presentation plan with the header. I also invite you to notice defined abbreviations in the bottom left corner. Software architecture design is an iterative and incremental process driven by the quality attributes. The process involves to select the most important quality attributes, to make decisions based on selected attributes, to describe the architecture and decisions, and to evaluate the impacts of decisions on project objectives. Each iteration increases the number of decisions taken. Organizations manage a design knowledge base to support decision making. In literature, this knowledge are grouped into 4 categories: general, context, design, and reasoning knowledge. This knowledge is commonly described as architectural style, architectural tactics, design patterns, and design decisions. For example, the software designer may decide to use the client-server style in order to improve interoperability between 2 software components, and the tactic increase available resources in order to improve component response time. To analyze and describe these decisions, the software designer can use catalogs of styles and tactics described in literature. A software designer should identify critical knowledge of a project and the appropriate solution. More exactly, the role of the designer is to identify valuable knowledge for achieving the objectives, discern what decisions produce the best balance between the objectives, understand the impacts of the decisions on objectives, and document decisions and related knowledge. My research aimed to develop an approach for inferring and sharing knowledge during the design process by managing the finer-grained design artifacts that constitute a software architecture. The first sub-goal was to define a reference model and description formats to describe the design knowledge and their relationships, to structure artifacts, and to describe the impacts associated with the use of artifacts. The second sub-goal was to develop techniques to systematize the use of the reference model, 2 techniques to populate a design knowledge base, and a technique to quantify and analyze the design knowledge in a particular context. I developed and evaluated my proposals iteratively and incrementally. The methodology I proposed to achieve my goals included 4 phases. A phase to collect data about existing design and knowledge management processes. A phase to develop the reference model used to describe architectural knowledge. A phase to systematize the use of the reference model. And a phase performed in parallel with the other phases to evaluate my proposals. During the data collection phase, I studied the design processes, activities, and tasks described in literature. I made a summary to provide a list of activities in order to support the identification and classification of design artifacts. I proposed to use the artifact as the basic concept for sharing knowledge. I studied the characteristics and relationships of artifacts described in literature. I proposed a definition for the concept of artifact and heuristics to support their identification. Based on the classification scheme proposed by Zachman for enterprise architectures, I proposed a classification scheme for artifacts related to software architectures. My scheme uses a matrix such as Zachman. I adapted to software architectures the questions proposed by Zachman to label the columns. However, unlike Zachman that uses perspectives to label the lines, I used the design activities to classify the artifacts related to each activity. I proposed to use the types of artifacts as a checklist to support the identification of artifacts and the inference of design knowledge. During the development phase, I proposed description formats to describe, infer, and validate knowledge. For encoding basic design knowledge and context knowledge, I proposed to describe each design artifact using a type of artifact, a noun or verbal group, an interrogative, and an activity. For encoding more complex design knowledge, I proposed to use traceability matrices to structure design artifacts. Each matrix is an instantiation of my classification scheme. I also proposed to use decisions points to infer the matrices and check their cohesion. I extended the list of decisions points described in the literature. For encoding reasoning knowledge, I proposed the concept of issue and argument. Firstly, I proposed to use an artifact, a verb, and a complement to describe and infer each issue associated with a design. I extended the list of verbs described in literature in order to manage the semantics and improve issues analyzability. I also made a summary of the knowledge management activities from literature in order to use them to infer and describe the issues related to a design. Secondly, for encoding more complex reasoning knowledge, I proposed to use arguments. An argument is described using an issue or a solution supported by a description of the impacts of artifacts on the relevant dimensions and activities of a project. Following my proposals and evaluation activities, I was able to establish my reference model. The artifact is the central concept of my approach. The software structures map is the matrix that regroups the artifacts relevant for a particular decision point. My approach aims to manage the artifacts and the issues and arguments related to their utilization. I proposed to use views to contextualize and analyze the related knowledge base. The following figure shows an overview of the SAM framework used to manage the architectural knowledge base. My framework supports a two-phases approach. The first phase, to acquire knowledge and describe artifacts, issues, and arguments. The second phase, to contextualize knowledge using quantified views to identify critical factors of a project. In order to support my approach with systematic techniques, a first step was to identify the activities to be defined and the roles related to these activities. The SAM framework defines 3 activities to be performed in parallel with the design process. 2 activities during which an engineer describes the knowledge, and an activity during which the designers analyze the knowledge. The first activity aims to identify the software design artifacts and create matrices of artifacts. The second activity aims to elicit the issue associated with the use of artifacts and describe the related arguments. And the third activity will contextualize the issues and arguments in order to create quantitative views of the knowledge base for a particular project. I developed 3 techniques to systematize the 3 activities. For each technique, I detailed the task, their inputs, their outputs, and the related work instructions. These figures present the classification technique. These figures present the argumentation technique. And these figures present the analysis technique. The evaluation phase allowed me to apply my proposal in academic and industrial settings. I applied my proposal to acquire knowledge from the descriptions of styles, patterns, tactics, and decisions. I also applied my proposal to describe knowledge used to design software cockpit systems and websites. All concepts of my reference model and a prototype tool was used during the evaluation activities. This is an example of a software structures map described during the development of a website. This is an example of 2 software structures maps related to a software cockpit system. This is an example of a software structures map that describes the tactic abstract common services. This research project allowed me to conclude that the SAM framework for inferring and sharing architectural knowledge is a step toward understanding, describing, and reusing the software design artifacts. The SAM framework meets common requirements and conclusions on software architecture design and design knowledge management from literature. The SAM framework addresses common issues related to design knowledge management, but issues remain. Future work will focus on the validation of the proposed techniques, the development of a tool support, user applications, teaching material, and the extension of the classification scheme to support implementation and managing activities.